Okay, so this will be mostly with the hands-on code, but first we will need to cover some basics, regardless of how familiar you are with the Solr search engine, just to create some baseline and to go over some specific stuff that we will connect to later on in the steps. Okay, so what are we dealing with here in the first place? Well, we are indexing content and locations, and we are also searching for them. So in this diagram, we see the representation of relation between content and locations. It shows that, first thing, that content does not have structure by itself. So by itself, we only have a pool of content. And what gives content a structure is a location. So location does not have meaning by itself. A location is always a location of content. Another thing, content can have multiple locations or none. On the other hand, one location always has exactly one content. And also content is what carries the payload. Content is what has fields, which is what we are interested in, right? Okay. So how is this represented in the Solr backend? Well, Solr indexes, stores documents. A document is basically a collection of fields with a unique ID. And Solr does not provide a way to relate between documents, which is actually not quite true. There is a way to do it. Solr does it with a kind of trick, and this is important for us because we use it. Okay, so each content and each location is represented by one Solr document. And this is done per translation. This means if we have one content in multiple translation, we'll have multiple Solr documents, one for each translation. And the same is the case for locations. For a single language, these documents are grouped into blocks. Block does not have an ID. Block is basically content with its locations. And this is a trick Solr does to achieve kind of simple hierarchical structure of relation. In Solr, this is known as nested documents or block join. And the trick is Solr stores these documents on the same physical block on the disk. And this enables it to join them very quickly. So for Solr, the speed is of paramount importance. And this is how Solr does this simple kind of structure. And this is what we use. So we have, for each language, we will have this block, which consists, again, of a content document and location documents. Okay, I don't know what is this about. Well, anyway, let's try it like this, not to lose time trying to figure out. Try to show briefly how we do indexing, a quick overview. And now we will go also quickly through the API that we have to search. So basically, we are using object-oriented way to construct a query by instantiating different objects, criterions, to build a query that is sent to the search backend. Here you can see a simple query with some logical criteria, section, content type identifier with some params, and so on. And this comprises kind of a tree-like structure. So in this example, logical OR would be the root on the top, and then it has children, section, logical end, and then logical end also has more children, and so on. And in the Solr engine, we are traversing this tree and translating it bit by bit, criterion by criterion, to something that Solr can understand. And we do this through small services called criterion visitors. That's kind of extension point that you can use to create your own criteria and your own visitors to extend the Solr functionality, Solr search engine. Okay, all right, there it is. And next, we also have a query object, which we fill with some parameters. And then we have search service to search for content or for locations. So these are two different kinds of search. We can search for content and for locations. Okay. Not yet the end. Now we can start with the code. Okay, to get the newest stuff, I would ask you to go to the this directory and do a git fetch to pull all the stuff, all the branches with the steps that we use. This is not on the virtual machine. So I hope you have internet connection and try to do that. If you succeeded to do a git fetch, then check out step 1_start branch. This will be our first step. Sorry? We have a step 1_start branch. This is the first one. Okay, I'm gonna assume everyone got that far. Before we start, I will quickly explain how exactly indexing works with Solr search engine. So we have a document mapper service which will convert content and locations into a Solr document that is then sent to Solr for indexing. This is implemented in a plugin-like way. So all fields are really indexed through a set of plugins. And these plugins are called field mappers. These are located here. Let me get back to the slides. So we have 5 extension points. We can, of course, we can implement our own field mappers. And we have 5 extension points where we can attach these field mappers to index additional fields with Solr. The first one would be if we want to index some additional fields on all blocks for specific content. The another one would be if we want to do the same, but for a specific language. Indexing for all blocks means indexing additional fields for all documents in the block, so content and locations as well. So these are 2. We can do the same for only content documents, so for all content documents or only some. And we can also index for location. So in the first step, we will implement a custom field mapper. Okay. So this is located in the Easy Solr workshop bundle, the core field mapper, content translation, and project parent film mapper. Oh, and by the way, we are using Easy Platform demo installation, which already has some fixtures. So we'll be using this site to show off examples. So here I prepared for you a skeleton of the film mapper, which has all the dependencies that you need. And your task is to implement a mapping of fields that will get the content name of the parent location and index it on the given document. So basically, here you will use injected dependencies to fetch what you need. So let me guide you through this. We first need to get the main location ID. We will get this from content. Oh, it's wrong keyboard layout. Where is this thing? Come on. Now this is on the version info. Now that we have a main location, we need to fetch it, right? So we'll get the location, and we'll use a location handler for this. And we will load the location we need, which is the main. Okay. Now that we have the location, we can fetch the parent location. So this layer, this is the SPI, is quite verbose, but this is what we use. This is the layer that we are in. So we can use the location and then use the parent ID. Okay. Now that we have a parent location ID, we can also fetch the content info for the parent location. Oops. Okay, I have a typo here. We also need a content type. And we'll use content type ID from the content info. Oh, I have load content info here. Okay. Okay. And we also fetch a parent content object. Oh, this is, by the way, all parent. We need to load the content by ID. All right. Okay. And I think we also need to provide a version. Version is here, required argument. So we will use current version from the content info. Okay. So now we fetched all the stuff that we need, and we need to use it to create a field that will be indexed. So this is still quite verbose in the SPI layer, but let's see how this would look like. Oh, sorry. Yeah, let me try to do it like this. Better? So we will first need to iterate over content fields. So we can access them like this. And the nasty thing here is we need a content field identifier, which is not really available on the field. So this is why we fetched content type. And we will need to iterate over content types as well, just in order to get the field identifier. This should, by the way, be parent content type, parent content. So we will have a nested for each. And yeah, first, a thing I forgot to mention to you is that we implemented a content translation field mapper. This basically means, if you remember what I said at the beginning, that we will index these fields on a specific translation of a content. So knowing that here content will have all fields, we need to skip those that we do not want to index. So we will simply check if the field language code is not what we expect. Okay, in this case, we will simply continue the loop. And if the language is matched, we need to skip all the field definitions that do not match our field. So again, we need an if check just to do this. And we will compare field definition ID. So now if this doesn't match, we will continue again. And finally, now we are in a place where we have the field that we want to use. So we really need an additional check to choose what field we want to use. We said that we want to index a title of the parent document. So we will write if field definition identifier is not title, then also continue. And basically in this place we have a field that is title in the English language that we want to use. And here we can set the variable. Let's just initialize parent title. I guess I have this below. So we set and we need to know what kind of field we are dealing with, and this will be a text line field, so we will just use field value data. So basically, that's it. We fetched the parent title. And we can use this to return a field that will be indexed. When we instantiate, we return basically an array of fields. We're not limited to return just one field. This is the search field. So this is from the Easy Publish kernel in the API namespace. It's Easy Publish SPI search field. It's basically a payload that contains data for Solr. It consists of name, of value, of course, and of type. And here you can see that for the name, this is the name of the Solr field, is meta content text. And this is basically a field that contains all text content for a content document. This is the field that we use for full text search. So this is how Solr does it. It fills all content in one field, and then for full text search, you search on that field. So you specify the name of the Solr field, the content that will be indexed, and you say what type of the field it is. So in this case, this is text field, and this is also in the SPI namespace. So if you are going to do this, you also need to familiarize yourself with this part. So this is basically, again, in the SPI search field type, and we have a set of fields that can be indexed in Solr. So with Solr, this is Solr search engine, or this is rather Easy Platform Search API. Solr field is abstracted by the class. And later on, if we have time, we will see also how to add a new Solr field. So basically, this does it.
One question.
Yeah.
The name of the field.
Yeah.
Is there some pattern that it needs to follow? Meta hash or something?
If you want to index a custom field, then, well, transfer directly, no, there is no pattern that you need to follow. But if you want to index custom field, you can enter whatever you want here. And then you will use the name of that field to search on it with the custom field criterion. But if you want to index content for full text search, then you will have to use this field, so meta underscore content text. So this is kind of a convention which is not exactly exposed or documented yet, but it's what you have to do if you want to have additional content for full text search. Okay. There is also another method that I forgot to talk about, and this is where we choose if we want to index given content. So this method is accept, and accepts content and language ID, and then we can check the properties of these parameters to return true or false, depending if we want to index something or not. So in this case, we will sorry? Should be executed at all, exactly. Yes. The thing is that here you will always receive content in all languages. So it's just the way the thing works. So we want to index a content type of the ID 5, and this is an image. In the Easy Platform demo, the image is used for a project, as we will see later on. So a bit weird, but the image content type is used to create a project object. And we also have only a single language, which is English in Great Britain locale. And that's it. All the other parts should be already configured for you. And this is basically registering this mapper in the service container so that the document mapper, the plugin system that is, can use it in indexing. So we have a service name, which is more or less arbitrary. We define it to something sensible to us. This is the class that we used. Dependencies, and then we have a service tag, which will tell the system what kind of field mapper this is. So in our case, this will be a content translation field mapper. So let's see how this works. Okay, so you can open in browser this URL. And let's just open controller. Okay. So we have a simple action that will search for project string, full test criterion for project string, and we just execute it and see what we get back. And what we do get back is this. And this is basically what you would get with the default installation. So in order to have this content, that additional content that we implemented through the field mapper, we need to reindex all the content so it gets to the Solr backend. So we will need to execute a reindex command. So if there are no errors, we have new content in, and this should now behave differently. Okay, so we can see we now have more content, right? We have images for which we indexed the name of their parent. So let's see how this looks in the admin. It will take some time for this to load. If you got stuck, you can just stash your changes and check out the branch step1_complete. This will contain the complete code for the first step. So it's this one. The username and password, it's standard for demo installations with Easy, and this is Easy Publish. Admin Easy Publish. Yeah, admin publish. Okay. bit constrained here. But here you can see that we have a project content, which is a gallery type that has concrete projects, which are of the image content type. And this is where we indexed the parent content for full text search. Okay, any questions around this? Okay, let's try to go to the second step. Next, we will implement a new kind of criterion, which should actually be, in my opinion, a part of the standard distribution. And this will be a criterion that will be able to choose content depending on if the specific field is empty or not. So this is quite useful, right? So you want to be able to, for example, fetch only projects that have an image, on only references that have a case study file or something like that. So there are lots of use cases for this case. So we need to discard our changes and check out the step 2 _ start. All right. So in order to implement this one, we will need, of course, a field mapper because we need to index additional stuff. But we will also need a criterion. And we will need to write a visitor for this criterion so this gets translated into something that Solr understands. So again, I prepared everything except specific fees that you should implement. And first, let's go over this stuff to explain it a bit better. So, okay, first we need to look at the API. So this is the criterion. If you remember from the beginning, this is the object that you use to build your condition for search. And we placed it in the API because that's exactly what this is. We extend the core criterion, which is in Easy Publish kernel, and also a criterion interface. The core criterion is basically a kind of best practice that we use, that you should also try to use, although you're not bound to use this. It basically breaks down the criterion to target. In our case, this will be a field that we want to match on, an operator, like equal or greater than, and so on, and the value that we need to match on. So we define constants, is empty and is not empty, that we will use in the API when building a condition. And then we create a construct method, which basically defines our API. So it receives a field definition identifier, for example, an image, and a value. A value in this case will be one of the constants. And we do some simple validation here, and then rely on the base criterion to pass on the parameters. The base criterion will use this method, get specifications. This basically tells it how to validate what you gave in the constructor. So the get specification returns an array of specification objects, which defines for what operator, what type of value can be given. In this case, we only handle equal, so we want to target to be equal to empty or not empty constant, and this constant is integer. We do not allow an array of values, so here we pass format single as opposed to format array, and that's it. We don't have to worry too much about it. The core criterion will read this and validate it. And we also have create from query builder value, which I believe is not used yet. It's used for the query builder service, which, as far as I'm aware, it's not finished yet or endorsed to be used. But we still need to implement this as it's part of the interface. Okay, so this is the API part. And we will look into the visitor for this criterion. Or rather, let's first look at the controller to see how we will use this API. Okay, so we have is empty field action. So we build our query, and we use logical AND to combine content type identifier. We will again search on the image, and we will define the condition for the caption field to be not empty. So we want to find images that have some content in the caption field. And that's basically it. We pass it to the search service and render the result. Okay, now let's take a look how is this handled for the Solr search engine. So this is where we implement a criterion visitor, which will process our is field empty criterion and convert it into something that Solr search engine can understand. Again, everything is prepared. We will need an SPI content type handler and also field name generator. This is also in the kernel repository, and it's the search namespace, core search. It's a common component, so this is intended to be used for any search engine. Visitor basically has two methods. Can visit and visit. In can visit, we basically decide what kind of criterion we want to process. So in this case, we want to process is empty field criterion. This is what I showed you just before. So we just assert that the given criterion is instance of is field empty criterion. And then in visit method, we need to return something that Solr can understand. First, we will need to generate a list of names that we want to match on. You saw in the controller that we want to match on the caption field. But we don't want to be limited to caption here. We want to index isEmpty information for all content fields. And this means caption, title, or whatever content field they might be for a particular content type. So we don't know that, and we need to do it programmatically so that we don't have to worry about it in the future. In order to do this, we have a getFieldNames method. Okay. So we basically just reassign some values. So target will be field identifier, in our case caption. And we also need to fetch a field map of searchable fields. This is available on the content type handler. And we initialize variable for field names. And then we iterate over the searchable field map. To search for a given field definition identifier. And if we found one that we use, so this will be a caption. We use field name generator to generate the name of the field in the Solr engine. So let me show you how this looks on a concrete example. So this is a Solr console that you can also access on your virtual machines. It's the localhost on the port. This is a standard Solr port 8983/Solr. And we select the collection we created. And we will query for everything just to see how our document looks like. So you can see we have 92 documents in the Solr backend. And let's see, there's a number of meta fields with the information like dates, section, owner, and so on. And then at the end, we will also have Solr document fields for the content fields. And these are created in this pattern. First part is content type identifier, connected with the underscore with the field definition identifier. And the last part is what defines the type of the field in the Solr schema. So in this case, this is a field for description field in the user group content type, right? And we also have value, which is used, well, single field can index multiple fields in Solr. It does not have to be only one field. For example, good example is image field type. So for image field type, we can index, well, let's rather find it and see how it looks like. Okay, I have a typo here. Okay, so now we have image fields, image content. Oh, so you have the class is called image. The field is also called image. But then you can see that we have altogether 4 fields for a single image field in an image content type. So we index file name, alternative text, file size, and MIME type. So in the code, this is what we need to generate. And the field name service is the one that helps us to do that. So we pass the isEmpty field. This part will be the one here. We pass the field definition identifier and content type identifier. And then we also pass the Solr field type. So in this case, the field will look like image. It will look like this. Right, underscore B because it's a Boolean. So here we will return all the fields that we can search on. Remember, we could have, if we are searching for a caption field, we could have that same field in different content types. So here we will need to return it for all possible content type where this field is searchable. Okay. So this is the getField method. And then we simply iterate through all the fields and create the match conditions. Basically a field name and the value. The value will be true or false. So we check the value on the criterion, which will be transparently converted to an array of values. So we need to access it like this when handling it in the criterion visitor. And then we'll simply check for the constant. So if the constant used is empty, then we set true, else we set false. And then we glue all these separate conditions into one condition, combining it with OR, and putting it into parentheses so it's separated from the rest of the thing. Okay. So this is about the criterion. Now we also need to create a field mapper that will index this information for us, so whether the field is empty or not. So let's see how this looks like. In this case, previously we created a content translation field mapper. Now we will create a content field mapper, which means we want to execute this mapper for every content field. So we do not really want it to depend on translation. Okay, again, everything is wired up. And in the accept method, we just return true, because we want to index isEmpty information for all fields. And yeah, I think we spent already an hour, so I think it will be better if I check out the resulting code and show you how that looks like, because we have a lot to cover here. Okay. Okay, so we will again need a content type, which we can load from the aggregated content type handler. And then we iterate through the content fields. Remember, these fields will be in all languages of the content. We also iterate through the field definitions in the content type and match it with the fields. And then we need a way to decide on a field whether it is empty or not. And this is where the real problem is, really. So we fetch the content definition so that we can get to the field type identifier. The field type is actually the service that has isEmpty method for a particular field type. So ideally, we will use field type implementation for a specific field type to decide whether the field is empty. But it turns out this is not really readily available. So let's take a look how this looks. Let's see how this looks for a simple field type like text. I will go to vendor, easy publish kernel, easy publish core field type text line. So every field type has this implementation. So we basically check the field type value object for the text property if it is null. So if we can access this, we do not need to worry for each field type separately. But it turns out that this service is quite protected in easy publish kernel. There is a field type service. This is by this is the repository API. This one is used to return the field type. This is the public API, the supported public API of easy publish. But it does not return the core field type. It returns like a sandboxed version of the core field type. And if we take a look here, so it does not have, it exposes only some of the methods that are on the core. And if we look here, okay. Well, you can see that there is no, oh, wait a minute. There is a, yeah, there is an isEmpty value method. But this one works with the API version of the value object. And this value object is not what we have available in the field mapper, because this is a layer below. We have a value in the persistence version. So we can't really use that. To be able to use this, we will need to convert the persistence value to the API value. And this is what's available on the core field type, but it's not exposed in the API version of the field type. So it turns out that we can't access the core field type. It turns out that we can access the API field type, but it does not have what we need. But there is also another version of the field type. And this is the field type for the persistence, which is exactly the layer that we are in. So we have a content with the fields in the persistence version. So this is located This is located in the EasyPublish core persistence. But here we also see that we do not have the necessary methods. We only exposed getEmpty value. So we will need to find a way to expose isEmptyField method for the field in the persistence format. And this is what is already done. So we basically redefined a persistence field type, extended the core version, and added the isEmptyValue method. And here we receive the field in the persistence format, and then convert it with the internal field type from the persistence value and then use isEmptyValue, which uses this is now API format, to decide if the field is empty or not. And we also need to implement a new type of field type registry, which is a service that holds the field types for the persistence, to use our new field type. And this is all already wired in the container. So we only basically need to redefine. This is the service name of the EasyPublish field type registry for the persistence. We redefined it to use our field type registry class, which returns the field type which has the method that we need. Okay. So finally, we can use this. We can use this to check if the field is empty. It's quite a bit of work to do a simple thing. But I hope this will also become part of the Easy, so it will be available out of the box. So we injected the field type registry. This is the persistence field type registry. And we get the field type service for the field type that we are handling in this iteration of the loop. And then, again, as in the first step, we create the fields that will be indexed. And again, we already saw this. We create a field object with the type Boolean, with the generated name, and we use the field type to check if the value is empty. And at the end, we simply return the fields. So, of course, this will not work without reindexing, right? Solr does not know any of this. So we need to, again, call, all right. Okay. Criterion visitor. Okay. That's better. Okay. So if we look at the controller again, we see that we searched for a field that is not empty. But it does not find anything because the fields are not indexed in the Solr yet. So we need to call the reindex command again. Okay. Let's try reloading now. And we basically get all the objects back because for all these objects, the caption field is not empty. Let's try to search for images for which the caption is empty. Let's see what we have here. Okay, so we don't have any. So let's go to the administration. Let's, for example, choose Hootsuite. All right. Logging again with admin publish. So we go to the projects gallery. Go to the Hootsuite and remove all content from the caption. So essentially making it empty. All right. Now this will again return 0, because although the change is committed to Solr, it's not yet available for search. I will show you how to rectify this, essentially lowering the, configuring the lower value for Solr to wait before making stuff available for search. But at this point, let's just call reindex again. And reload. And now this is available, and we can search whether the field is empty for any field type. And if we go to the Solr console and execute the query again, seems not to be here. I don't think this is responding. Oh. All right. So let's see what we have now. Oh, this is weird. Okay. So we can see for the image name, we have is empty information, for the image caption as well, for the image, name, and so on. And this will be the case for all fields in all content of all content types. Okay, any questions around this? Okay. Then we can start on the third step. Here I will show kind of a counterpart to the first step, where we indexed a parent content on the child. Now we will index child content on the parent, right? And we will discover if there are any problems here that might bite us. Okay. So let's just check out everything. I will again go to the complete version. Okay. So here we also have a content translation field mapper. and we will index author names from the blog posts on the blog, which is container for the blog posts. Okay. So this is a container which is called top stories, and here we have 3 blog posts, and for each of these blog posts we will find the author name and index it on the container. Okay. If you set out to do this, you will quickly discover that in the SPI layer, you have no way to load children. The only way to do that is to use search. But if we are indexing content in the Solr, previously you saw that content is not available immediately for search. If we use Solr to find stuff and also to find stuff for indexing, the things might not yet be available. For example, we encountered this problem when doing some import scripts. So we were indexing things during import, and then we were also using search to find things that were important and to do some logic to decide how the content will be structured. And the problem was that the content was just not available yet. So this was a no-go. So how we would solve this problem? I think this is a really missing piece in Easy Publish, because it does not provide a way to find content that is not synchronous. If you use Solr search engine, then you will also have other problems which are kind of hidden now. For example, there is a number of API methods that in the background are using search. For example, let's see, delete subtree. If you try to delete subtree, the system will transparently, the logic will use search to find any content in the whole subtree that you might not have access to edit. So it needs to check permission. And it uses search to do so, because the permissions are interleaved in the search conditions, right? So you use search to find if there is anything in the subtree that you should not delete. And then if there is, the unauthorized exception is thrown. But what if the content is there, it's just not available for search? So this is kind of a security problem, actually. And there is another problem with the, I think, move subtree. So you also need to use search to check for permissions. So you see, it's kind of a missing piece. And there are also other issues. I will not go over them here, but solution is actually already available. It's not in the API, but we actually already have a filtering engine, meaning a search engine that does not depend on time for content to become available for search, right? And this is called legacy search engine, which works directly on the database. So this is what I did in this step. I will show you how to get the legacy search engine so that you can use it in your time-sensitive indexing services where you need to find content for indexing. Because if you are using Solr, if you use Easy API, you will use Solr. Yeah, go ahead.
Well, that's technically kind of run, so we probably do Solr.
Yeah, I actually opened a pull request a year ago on that now. Yeah. Yeah, well, it needs to be unlocked first. So basically, if you use Easy API, this API will be based on the Solr backend. And this is where the problem comes from. What you mean? What we need in filter service, or?
So the question was, why don't we use the API to look up the location?
Yeah.
So we can technically look up the location by ID, that's safe. But it's in certain cases where it's like asking for children,
Yeah.
or maybe one other use case, the search is used.
Yeah.
We currently use the Solr to do something.
Yeah, exactly.
That's the issue.
Yeah. So basically, there is no way to fetch children without using search. It just does not exist. You can either, there is only, in Easy Publish, Easy Platform, there is only two ways to load something. You either load it by ID, in this case you already know the ID, or you use search. Okay. So let's see how this looks like. It's actually turned out to be really simple. And we already use it in our site API. But also it became quite frustrating to create content in admin. And by the way, we still use legacy admin, which is integrated with the Solr search engine through Easy Platform Search. If you are still using legacy, you should look into this. It's netgen/Easy Platform Search. And it actually uses, it has, for some cases, for indexing, it has no way to index immediately, but needs to register a pending action item, which is processed by the cron job. So the stuff is just not available for search. And when you're building a site, it becomes quite frustrating to create something and then don't see it on the front end. It's a real pain. So to work around this, we created a filter service in exactly this way. This service already exists in the, well, this is the name. The name is specific to this workshop, but basically the definition already exists in Easy Platform Core. We just redefine it here, and instead of the search handler, which in the case of the version in the core, is resolved through the semantic configuration. So basically what you configured. We use directly legacy search handler. And we need this only as a factory. If we want to fetch the search service, we define it like this and use the service above as a factory to get it. And that's it. That's all it takes. It's some 15 lines of code, and you have basically what I call a filtering engine. So we only have a few minutes, so I will just show you that this works. So let's take a quick look on the mapper. It's a blog children mapper. Basically defines a search query for a parent location, which is the main location of the given content. And then it says we want blog posts, then finds that content and iterates through all the hits and extracts the author names. And then it returns the result. So if we go to the step 3, which is index children part, if we search, well, let's look for the controller. Okay, this is the index children action, and horizontal scroll is not working. Okay, so we basically search for the phrase, which is the name of the author, and just spew out whatever we get back. And without reindexing content, we only have a blog post. And if we call reindex command, we also have the container for the blog post. That's it. Okay, so it's 11 o'clock. I think we have a 15 minutes break now. So let's try to start the second part in time. Okay. So in the next step, well, let's take a look how the system works when you do a content search that involves some conditions on the location properties. So, for example, how the system works when you search for content and you use criterion visibility. So as you know, content can have multiple locations, or none. Okay, in order to discover this, wrong key. Okay. In order to discover this, we will take a look at the indexing plugin that is Field Mapper, which comes with the Solr search engine. Okay, so we need to look how the location fields are indexed on the content document. And that should be here. It's content document location fields, clear enough, field mapper. So let's see. So basically all fields in the search engine are indexed through the plugins. And this is where it happens for the location properties of the content. Okay, just to quickly reiterate for the people that just came in, we are looking into how the location fields are indexed on the content document. Okay, so here we have map fields, we receive content, and then we find the location properties. And we use the location handler to find all locations of the content. Then we iterate over them and collect the stuff. We collect the IDs, the parent IDs, remote IDs, path strings. We also collect the information if some location is visible. So, what does this mean? For example, if you create a content query with a condition that it needs to have a location that is visible, it will match if there is any location, if it has any location that is visible, even though it might have other locations which are not visible. And there is no way to assert that you want to check that you want only a content that has a visible location in a subtree. You can't combine, basically what it is, you can't combine conditions for a location. The conditions for a location apply on the aggregated data, and there is just no way to do it. And for some more complex content modeling cases, which we had recently, I think it was something about site about medicines, drugs, which had some complex structure, quite elaborate. We needed this to find some data, and we were not able to do it because it's just not supported on the content, right? But remember what I showed in the introduction. We saw how the content and locations are indexed into separate documents, and these documents are grouped into blocks. So the stuff is already structured. It's prepared for us to use it in order to make this possible. It's just not implemented yet, and we will show how to do it. It's actually quite interesting because all the things are already there, and aside from all the wiring that you need to connect them, the thing boils down to one line. Okay, so first, let's take a look. Let's take a look how we already use some of this for the full text criterion. Okay. Okay, seems I need to do this like this. Okay. Okay, so here we have a criterion visitor for the full text criterion, which is used in content search. So let's see what this does. So this is the one that does the whole job. It calculates the fields, uses the field name resolver to get the field type information. It matches the meta content text field. It adds boosts, combines with the OR, also escapes, applies fuzziness property if it was used, and so on. So this is the one that does the bulk of the work. But we are actually interested in another one, and that is full text criterion visitor for location search. So this is separate. Because we only index stuff for full text search on the content document. It's not on any of the location documents. You can of course do it, but it's not what is done in the engine by the default. It's not what's recommended, because if you would do this, you would mess up the statistics. Because Solr is all about search relevancy, and if you index same things multiple times on multiple documents, it will mess up relevancy, basically. So you want to index it on the content. So let's see how full text criterion visitor for location search looks like. It actually extends the visitor for content search. And it uses the call to visit from the parent, escapes quote, and uses something that is called block join query parser to join the location document that we are searching for with the content document. So remember I said the blocks are an efficient way that Solr uses to make a relation, the hierarchy. And this is where we use it. It's quite simple. So we search for locations, right? So we say, these are all, by the way, these are all documents, meta fields in the Solr document. So we basically say we want a child of the content document, which is location. And this content document, it must, of course, be of the type content, has this condition that was defined in the full text criterion. And that's it. It just works. Now, what I described at the beginning, we want to have a way to, in content search, to group conditions for a specific location. So we kind of need to do the opposite of what is done here, right? Here we search for a child, and in what we are going to implement, we will search for children, because locations are children of content. Okay. So this will be step 4. Okay. So let's check out the complete version of step 4. Okay. And let's see what we have. So how would you design this in the first place? You basically need a way to group conditions for a location. So let's create a location query criterion. This will be similar, for example, to the logical end criterion that combines criterions, different criteria. So, of course, we first need to define it in the API. And it's rather simple. It's trivial even. That's all of it. It basically accepts in the constructor, it accepts a criterion, which will be a criterion for locations. So it can be one, or of course, it will always be a root. You can use, for example, logical one and combine then criteria for locations, right? So we only accept a criterion object here. And we rely on the base implementation of the criterion to handle stuff. We only define the equals operator, and that we do not accept an array, but only a single criterion. And that's it. Then let's have a look how this will be handled. So we need to have a visitor for this criterion. And it's a separate service. And actually, we do not need to define this service, because we already have one that is used for location search, right? So let's see how this looks in the service definition. Okay. This is the one. We did not define this by ourselves. This is already this already exists in the Solr search engine provided by EZ. So we just inject it, and we of course need to tag it with the service tag so that it is recognized. Again, as you saw in the isFieldEmpty criterion, we need to check if the criterion can visit. We handle location query criterion. And then we implement a visit method. The value of the criterion is actually a location query, right? So it's a criterion. We call it a query, but it's a group of conditions for a location. We use the aggregated, the visitor that we injected to visit it. And basically here we will get back the location conditions that Solr can understand. We'll use this in the block join query parser, which now uses this syntax. Previously we had child. And because we use it in this format, so basically behind single quotes, we need to escape the quotes. Additionally, I did not expect this, but I found that slashes, I found out this when using path string criterion, slashes needs to be double escaped. So they are already escaped by this method. But we need to escape them again. And then we say, we search for a parent, which is content, with the children that match this condition. This is basically the meaning of the thing. Now let's see how this looks on the Solr documentation. So this is a page on the Solr wiki, which lists all the available parsers, query parsers for the Solr. Seems that this will take some time. Okay. So you can see there is quite a number of them. And we are interested in the first one, block join. You saw in the full text criterion, we used block join children query parser, and here we use block join parent query parser. Yes, exactly. This is made for nested documents. Yes. 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 Yeah. Yes, exactly. The benefit of having nested documents comes with some limitations, and it's you need to handle block as a whole. So you can't just add another location. If you add another location, you need to reindex the whole block, and that means content and all of its location. But this is actually how Solr works. It does not do update. Even I think in later versions, it got some update functionality, but I think this is in name only. It does not update. It deletes and recreates, really. This is true, but it's of course, it's completely transparent. To us, this is handled by the Solr search engine, so we do not need to worry about it. And regarding indexing, that's not what causes the problem, really. But yeah, we'll get to that again. Okay. So basically, this is it. This is all we needed to implement this functionality. And it really opens, I think developers in Edgen told me that they might actually use this more often than location search, at least for some use cases. It will come quite useful. It opens a whole new class of way to structure content, to model content. Because now you can search. Let's see how the controller looks like, controller action looks like for this. Right, so we have location query criterion action. And this is how it looks like. You can even use multiple location query criterions. So here we are searching for a content with the ID 62, but which has a location 64 that is hidden. And it also has another location that is visible. This is just to demonstrate how this works. Of course, this is not particularly sensible use case, but let's see what's going on. So of course, yeah, we do not need to do any indexing here because we did not do anything new on the stored data. We only use it in a new way. So let's see what's going on. Okay, so we didn't find anything. Let me just find my cheat sheet with the IDs. So we said we are searching for a content, if I remember correctly, for a content with the ID 62. And this is again Hootsuite. And the location 64, it's only and main location right now. So what we are going to do, we are going to hide that location. We are going to add another location. And then this query should match, right? Okay. So let's do that. And I did not do this intentional, but I need to load the, oh, right. Thank you, Firefox. Okay, so going to the projects gallery. Hootsuite. And locations tab. Okay. So first, let's add a new location. We'll do this under top stories, let's say. Okay, confirm selection. The UI does not display it, but it is here actually. So we need to reload it. Okay, this is not going to work, I guess. Should we make a break or no? No. All right. Oh, and it's not indexed yet. Okay. So let's do that. Okay. And repeat this. I executed reindexing.
Yes, for example, if you click on projects, you want to find
Oh, okay. Yes, you're right, of course.
working together.
Thank you, but too late. We don't use it, by the way. All right, so it's here. So this is the default one, which is visible, and this is a new one, which is visible. And yeah, let's hide it. Of course, this will not work without reindexing again, unfortunately. So we didn't find anything. But after reindexing, I hope this works. We found it. So it works. The future improvement to this that I think should be useful would be returning the information on what exactly location matched. So, for example, if you would want this in order to create a link, perhaps, or something else. And this is possible. Solr has a feature called data transformers, and this can be applied to return the information on what exactly location of the content matched. So I will also make a pull request for this to be included in the easy search, Solr search engine, the standard distribution, and probably also work on this improvement as well. But now let's quickly take a look what we can do in order to remove this delay between stuff becoming indexed and becoming available for search. Okay. So to do this, we will need to switch to the Solr user because this stuff is protected for our user here. So you can write sudo su -solr. The password is same as the user, that is websc. Well, okay. And the Solr configuration is, well, first let's stop the Solr service. What's going on? Hmm? Okay. Okay. Yeah. No, never mind. Okay, so that's still there. All right. We need to stop Solr because it will not pick up the configuration changes otherwise. So we go to the var Solr data collection configuration. And let's see what we have here. The setting that we want to change is in the Solr config XML. This is also documented on the Solr search engine itself. Okay. So on the README file, actually, it says that in order to improve the delay between things becoming available for search, you can lower the auto-soft commit parameter. So let's do that now. So was called auto soft commit. All right. Okay. As you can see here, it's actually disabled. So let's change that, and we'll change it to, as suggested, to 100 milliseconds. So 10th of a second. All right. All right. Okay. So let's just check once again that everything works. Okay, it works. And now the changes to the location visibility should be nearly instantaneous. So if we hide this one, it's not there. This will, if we reveal it, it appears. But of course, this will work well only with the completely new stack. If you use hybrid stack, as I mentioned, you need to integrate the back office with the Solr search engine, and it needs to use pending actions and cron jobs, and it will not be instantaneous, and you will have issues. Yeah. Yeah, it does stuff inside of a transaction. Yeah. And the new stack uses another transaction and does not see changes yet. So it's quite a weird solution. We catch not found exceptions and then create the entries in the pending actions for indexing by cron job. But it kind of works. Okay. So that's it regarding the location query criterion. If you have any questions before the next step. Okay. Okay. We don't have any changes, and we will go to the step 5. Step 5 does not have start and complete versions because I didn't anticipate to do any changes here. I only want to demonstrate, this is a small library that I implemented several months back that enables us to implement a better full text criterion. I don't know if you are aware of this, but the full text syntax that Easy Platform supports with the full text criterion, it's quite sad actually. It does not support anything. It does not even support quotes. Everything is just escaped. And this is sad because we have Solr beneath. And Solr have quite nice search syntax. This is the search syntax that is already known to all of you. It's basically standard. It's used in every search engine you know. So, for example, Google, you have and or not operators, you have quotes for phrases, you have parentheses for grouping, you have plus, minus, and some quite nice stuff that will be quite useful to have in a search box you implement. So if this is the case, what is the reason that we do not support it? Well, the problem is, let me open this Solr issue, and I will also open Solr this max query parser. This is query parser that is exactly intended for search as a user input. So it has all the things I mentioned. It's also resistant to errors because we are dealing with a user input. This needs to be the case. But the problem is, aside from everything I just mentioned, it also has so much more functionality. It can use nested queries with underscore query, underscore syntax, function queries with val. You can use boosts with the caret operator. You can use fuzziness with the tilde. You can target a specific field. You can do all kinds of stuff. And it's very difficult to control it. What we are dealing here basically is language. And if you try to control it through some regexes to some escaping replacement, it's a really poor solution and you are not going to get very far. You really need to go for language processing. And for this use case, it seems quite an overkill. So let's see this Solr issue. It's basically an issue to allow controlling what features of all the features I mentioned the query parser will support. For example, a possible set of parameters. This is the comment by author. You might want to have Boolean operators and or not. Ranges, I didn't mention it. You might allow ranges or not. Fuzziness operator, wildcard, parents, boosts, field wildcards, and slopes, and so on. So there is quite a lot to control there. And there has been no work done on this in more than 5 years. So basically, it seems that nobody cares about it. It's what it is. And this is the Solr side of the story. We also want to eventually support Elasticsearch. And Elasticsearch has its own flavor of this syntax. So if we want to have one API that covers both, we need to abstract it. And again, it will be a very poor approach to try to do this through regex and I don't know what. So I was quite frustrated by this for some time, and then I decided to do something about it. And I implemented a small library that defines a language and implements a language processor, a full stack. Basically, it has a tokenizer, parser, generator. It's kind of a full compiler and translator, if you will, producing. Well, let me show you how this works first. It's on the GitHub. You can also try this installation. It's rather simple. Under netgen, and the library is called Query Translator. Okay. So it has very simple instructions to install it and run the demo. So we are going to do that first. Okay, we are not going to do this here, but above this. Okay, I already have it actually, but let's do it afresh. Playing with fire. Okay, I need to paste it with the Shift Control V. All right. Yeah, okay. Well, some artifacts. Okay, then we are going position to position into it. And let's see what the instructions say. We'll generate autoload. And then we will start the embedded PHP server on the port 8001. All right. So now we can access this and see the demo. So this describes the basic syntax the thing supports. You can see that we have phrases, groups, plus and minus operators, and or not in 2 different versions. We also have tags, and we can use kind of domains. It's not explicit field matching, but for example, you could use this to define a type domain and then map this to the Solr field. What I will show you is the text variant, which is more limited than this and supports only basic syntax available, important for text search. For example, the parser creates a syntax tree, and this is always quite nice to have, because once you have a syntax tree, you can quickly visit it, easily visit it into anything you need. So in our case, for Solr, or something for Elasticsearch, or maybe even something for the SQL. Quotes in a phrase. Yeah, it's it recognizes a phrase.
Yeah, this is great. But inside the phrase, searching for value with a double quote, right? Value containing a double quote.
Okay. So for example, if you do it like this, it will recognize an error. So it will say, parser ignored bailout token. So it could not match this last quote with anything, so it ignored it. But you can also escape it, right? What is the backslash on the keyboard? Yeah, you're right. Okay, no corrections anymore. So it actually has quite an elaborate system to recognize errors, and it's fully resistant to errors because this is about user input. And you can also use OR operator, and you can use grouping, the whole shebang. It just works, and it's quite fast. So let's see how this works for us. So I think I already checked out this. Okay, we don't need this anymore. Right? Everything is already prepared. So we have a query translator YAML, which configures the available services and implements also a new full text criterion that supports this syntax. So we have a new full text criterion. And there's not much point. I'll only want to show you that this is available, and in the case that you need it, that you can use it. Let me just show you also a demo on this demo installation that we have. For this to happen, we'll first need to install the library through the composer. So we'll do composer require. Net again. And by the way, you will need to do this if you are following on your virtual machines, because next steps will depend on this. Tilde.
Shift and the bottom left from the one.
You don't have to specify version of the automatically.
No. What?
You don't have to
Oh.
specify version, it will pick it up automatically.
Okay, just like this.
Yeah, but you're missing the S translated.
Okay. All right, let's try that. Takes a little bit of time. All right. I think I actually need 101. This will not work. Okay. And there we go. So we have step 5. The path is better full text, and we have a search field where we can use this syntax. So for example, security, and then this is, by the way, project, as you see, and then you can say security or Europe. So it will find either security or Europe. And then we have space. So let's group this like this: Europe and space. And it works. And this is so much nicer than having basically just words. Sorry? And you can also use phrases. And so on. And if you need to customize it, it's also quite easy to do. It was made to be easy to customize. So you do this by adjusting the token extractor service and by adjusting regular expressions. So for example, we could use this to translate the operators in German. So it would only involve this. Or you could decide that you do not want to support parentheses, then you would just, where is this one? You would just comment out the line that recognizes the parentheses, and that's it. So it's really trivial to customize. And so much for that part. We can go to the next step, and this is more like this criterion. All right. Okay. So I don't know how many of you are already familiar with more like this functionality in Solr. No. This is basically a way for Solr to internally what it does, you tell it that you want to find more content like a specific content, so a specific document ID. And then it internally will read that content and it will create conditions as it sees fit on the terms in the document, and it will return to you a list of more content like that. So it's basically a way to implement a simple recommendation system, let's say. That would be one use case for it. It's quite often requested. Yeah, it does. Yeah, good. And until Solr 4, this was only available as a separate Solr resource. So you have a Solr resource for search, for example, /select that you send. It's a REST endpoint, like an endpoint on which you send your request and which responds. This was available only as a separate resource, MLT, that you were supposed to configure in the Solr config. And in order to implement it through that, you actually needed to override the whole stack. So because the search engine is not implemented to support extension for such use cases. So it was we did it, but it was quite complex to do because you had to duplicate the whole vertical, and that means the search service, search handler, gateway, the whole thing. But with the Solr version 5, this became available as a query parser. And that means that it's possible to implement a criterion that will work with it. So we can use more like this criterion and find more content like this very easily. It's actually quite a powerful thing. So let's see what we have. Again, we have more like this criterion. This is what we will use in our query. And again, it's trivial. It accepts content ID and language code because it needs, we remember we store documents per language, it needs to match a document in a specific language. It's also important to note that this will I think this makes sense only with content search, because the content is where the language is stored. So location does not index any terms, and if you were trying to find more locations, like this content, it will probably return some garbage. It will not work well. Yeah, makes no sense. So basically, if you remember in the beginning, I told you about a little bit about the base criterion, and that it recognizes a target, an operator, and value. In our case, content ID. You don't have to specify all of these parameters. The base criterion will take care that if you omit some of them, that it will make a sensible decision. For example, if you omit the operator, it will assume that it is equals. So in this way, you can build a nicer API. But for some criteria, you also need to pass an additional parameter. So far, in the standard distribution, this is the case for the location distance, map location distance criterion. So for example, you want to find, you have geolocation in your content, and you want to find all content of some type that is within some distance of that location. So you, for the target, you use the field name. For the operator, you would use, let's say, less than. And for the value, you would use, for example, 10 kilometers. But this is not enough, because you also need to specify a location where you are, right, for reference. So this is a fourth parameter of the base criterion that you will only rarely need, and it's value data. It's like a payload for the value, like something like a contextual data for the value. This actually has a base class, and it's rather simple, really. Here you can see we have map location value, which has latitude and longitude. And in our case, we have language value, which simply carries a language code. This is just a mechanism to pass the additional data that we need to the visitor, right? So much for the criterion. Let's see what we have in the visitor. All right. So Solr doesn't really care about our content and location IDs. For Solr, it's just fields. Solr works with the document IDs, which are something unique, and which we generate. And these are different from the content IDs. So in order to get this from the content ID and the language code, we need to use document mapper. This is the service that creates the whole field mapper plugins system, and which also then creates a unique ID field. So we will use that. We just injected it. And we fetch the language code from the criterion, this language value, and then call the method on the document mapper to generate the content document ID. It's quite simple. So you just call it with the content ID and language code to get the document ID, and then return the format of the more like this criterion, which will operate on the field that indexes all the terms for a particular content. So let's see how this works. We don't need really to enable this by some configuration option. It's available out of the box. And we don't need to reindex anything. It just internally does its own search and returns results for us. So let's try to find something that is more like something else. Right. Let's see what we have in the workshop controller. Okay. So quite simple, right? I did this in order to combine with logical AND to introduce some more criteria, but here we have more like this content 78, which is a project called La Nouvelle République. But we can also try with the content with the ID 42, which is user group type, anonymous users. So let's see how that works. Yeah, it's not a typo, it's a bug in a document mapper. Because the Solr will remove the dash when indexing. And this, I guess this was never used outside of indexing. We need this to make a query and not index stuff. So let's see what happens when we change to more like this anonymous users. Okay. So it finds more content like anonymous users. The thing is, the fixture in this demo installation is quite small. And really for more like this to show what it can do, you need lots of content. So the more content you have, the more relevant information it will return. If you have a small set, then it's bound to return something that might not seem too sensible, right? Because it has a little to match on. Okay. No questions around this? Then let's move on.
The reason for this is basically because the scoring in Solr is calculated from the amount of items that it found, from the amount of documents that it found, and then it cross-references. That means this, if you remember, this is really complex mathematical equation.
Yeah. When we debugged it, yeah, if you have a little content, you might have in this calculation, you might have numbers that are out of proportion. And okay. Next thing we'll see is how to implement custom facet. We will implement what I guess I should explain what a facet is before for anyone that might not be introduced with this. A facet in Solr is basically a way to categorize content. So if you defined a query with a facet on a specific field, for example, let's say content type ID, Solr would return the search results to you, but this response will also contain the information about facets, and it will contain statistical data about returned content on the content type ID field. So with this, you will get back the information in all the results that you got back. You have, I don't know, 25 articles, 17 blog posts, and so on. And you can use this almost with any field. For example, if you use this on a tag field, you will get information about how much tags, how many content is tagged with a specific tag, and then you could use this to build a tag cloud with the bigger tags displayed in a bigger font. If you would use some kind of function to translate the count into the font size. Okay. So let's look into how would you implement a custom facet. This is the step 7. All right. I'll never mind all that. Okay. You can just remove all the changes to composer JSON alloc. It doesn't matter at this point, really. We have the dependencies already installed. Okay. So how is this facet thing implemented in Solr, for starters? Basically has 3 parts. First one is the facet builder, and it's an object that you use to define for Solr what you want to get the facet data on. So this is in the API, and we have custom field facet builder. And this has, it's quite simple. It has 2 parameters, field name, because this is for a custom field. So here we will provide a field from the Solr document, the exact name, and sort, which is for facets. It's for field facets. That is, it's limited. It can be by count descending or by term ascending, and that's it. But this is usually not a problem because you only get back a limited number of facets, and if you need something else, it's easy to do your own sorting in PHP. Okay, so this is what we use to define a facet. Let's see how this looks in controller action. All right. So you define a facet builder. These parameters are inherited from the base one, so it's not actually this simple. It has a little bit more. The ones we care about here are limit, so the number of facets we want to get back, sort, what we defined on the facet builder. The name, this is used for referencing when you get the data back. And field name. And we use the content type ID field. And then we construct a query. We do not provide any limitations. So we basically want to have a faceting on all the content in the repository. And that's it. So, facet builder, one part. When this is returned in the search query, in the search result, that is, you will get the facet data. And let's see from the template how this looks like. So on the search result, you have a facets field with an array of entries. And each entry contains a key and the count. This list of entries actually depends by the facets, and this is abstracted by another object, which is the facet itself. So this is the data that was returned. And this one is quite simple. It just contains list of entries and extends from the base facet, which just has a name. This will be the name that we defined on the facet builder, right? Okay, so this is the API, and we will also have a visitor for this facet builder. So it's a custom field facet builder visitor. And actually this visitor has a dual function. We have a private method for sort to translate what we defined for Solr. And then we will first go over can visit. You already saw this in the criterion visitors. So basically we just decide if this facet builder visitor can handle a facet builder we defined in the query. So it just returns a Boolean. Then it visits the facet, converting it into something that Solr can understand. And in this case, this is typical, by the way, for the field facets. We defined a field on which it operates. We defined a limit, min count, like a threshold, and sort. I will get back to this method. So this is one function it has. Another one is mapping of the returned data to the search response. And this is done by the map field. And here we instantiate the second object regarding facets that I show, and populate it with the facet builder name and call the map data on the base facet builder visitor. If you used facets already, recently the API was changed a little bit. Because previously you had, it's very similar to what you have now. You had can visit paired with visit builder. But with map field, you also had a method to decide if the facet can be mapped. I think it was called can map or something like that. This was simplified, and this field ID that you see defined here is actually an object hash from the PHP SPL library, unique object hash, that is used so that we got rid of this one extra method. So this is a way basically for Solr with this will be a basically hash like you would get with the MD5 function or something like that. With this, we say to Solr that we want this data mapped by this field, so we can recognize it. And this is used then in order to decide if the facet builder visitor can map fields. This is, if you are interested in this stuff, this is by the way done by the let's find it, result extractor, right? This is the service that does all extraction of the Solr response to the search response. And if you would ever need to customize something, you could use this. For example, one thing could be that you want to add some extra data to the search response. For example, Solr has a stats component that you might implement, and then you have some extra data. You would be able to define a new search result that extends the base one and populate it with this extra data. And the search result created here, it goes through all layers. So we don't have one for the search handler and one for the search service. So basically what you do here will be available you in the search service as a response from the search service. Okay, so this is also where the facet builder builders are handled. And just to mention this, in this logic, we handle the structure returned by Solr that is adjusted for the field facets. But this is not the only kind of facets that Solr supports. You also have range facets that you could use, for example, to implement date ranges. This is in the API, it's defined, but it's not implemented yet. What else do you have? Sorry? I didn't get it.
Some kind of query?
Yes, exactly. Yeah, I think it's actually called query facet. No, yeah, something like that. There's all kind of different facets that exist. So far, we only support field facets. For example, if we wanted to support, if you had such a use case, you could implement a date range facet, and then you would need to override this service and to handle the data structure returned by that facet separately from the one that handles field facets. All right. So let's see how this works. Okay, so we defined a facet on a query without limitations. So this basically breaks down the type of all content in this repository. So you can see that we have 24 images, 6 folders, and so on. And that's how you implement a facet. Now let's change the field that we are faceting on. So here we used content type ID. Now let's use, I'm doing this from the top of my head, image, well, no. Let's consult Solr. Okay, content name, underscore S. This will be interesting. Okay. We also need to adjust the template, because here I mapped the content type IDs to content type identifier. So we'll just remove the mapping. So let's see what we get back as a name. This is not particularly sensible because it will all be, the counts will be 1, because the projects have distinct names. But let's see what's going on. So basically got back project names and count of the projects with that name. But you might, if you look closely, you might notice that everything is lowercase. Herway here had this problem recently, very recently actually. This is why I decided to put this in the workshop. So he needed to facet on a field and then discovered that everything was lowercase, and he needed to display this. It was not simple to just capitalize the sentence, and it had some more complex meaning than that. So it was a problem. So we needed to look into how to get around this. Well, how you get around this is basically by implementing a custom field type for the Solr. If you remember, I showed you, let's see one of the mappers. You could, I think you could also use that, yes, but it will be like a hack or trick solution. If you wanted, there might be other use cases. You might want to index more data under some differently analyzed, different Solr field. So I wanted to cover that case, those cases also through this one. All right, so we are going to look, well, in some field mapper, not this one. So you remember we had text field. We also used Boolean field for isEmpty. So these are the field types I'm talking about. We use this term on multiple places. So don't confuse it with the easy publish field type. This is basically, this is a list that we support. We abstract the field in the Solr. So if for the string field and the schema that is distributed, this will always be lowercase. So if we wanted to implement case-sensitive string field, we will need to implement a new field type. And we will also, so basically we will need to implement a new class here, but we will also need to define it in the schema. So define it for the Solr, how this field behaves, how it's analyzed, does it do any the processing, tokenizing, and so on. Okay. So I think this is a step 8. All right. Not that. It's too much open stuff. So you remember, this was defined in the SPI namespace. So the first thing we need to define here is a new search field type under the SPI namespace in our bundle. And this one is quite simple. We will extend string field because there is a small service that does mapping of the field values by the field type. For example, if you pass a Boolean value full of false or true, this small service will convert the value into string false or true. So it does also something for. It also does something for dates and so on. So it does quite simple mapping, but we don't want to introduce a new mapper. So we will do this trick where we extend the string field and rely on the field mapping system to handle this one as well. So we defined the type, which is basically a unique string. And this will be used, this will be matched with the configuration from the container, as you will see, to create a suffix for the actual Solr field type. We can also look a bit in the base search field. So this is the string field, but also it extends the base search field type, which has some quite interesting stuff. For example, multi-value in the result, whether the field should be part of the resulting document, boost, highlight, and so on. Unfortunately, none of these are really implemented. Well, I'm not even sure if this is going to be implemented in this model, in this way. It needs to be researched a bit and designed and decided how would this eventually look. So this is one part. We also need another part, which is setting. So this is redefining of the setting from the easy publish core, which defines all the field types and the suffixes that will be used. So we need to repeat everything because we can't just append stuff. And then we also define the suffix for our field type. So case-sensitive string, CSS. The string field type that easy uses is always lowercase. So you might not have noticed this because only now we are working on the returned data from Solr. Yeah, we can. You mean usually with Solr or with Solr search engine? Okay, let's find out. Yeah. Yeah. Yeah, we have a schema right here. So, right. So this is the default schema, and here we have a string field, which is actually lowercase. Yeah. I think that we should definitely index more different fields. At least this is what EasyFind was doing. You had the fields, all kinds of analyzed fields. It was done out of the box. And yeah, it just needs to be done. Someone needs to do it. Okay, so one part search field, second part defining the extension, the suffix for the setting, and the third part we need to define a new field type in the Solr schema. So we will basically define maybe same like this is. We will remove lower. Okay, I can't edit this. I don't have much time to finish this to the end. We will remove lowercase filter factories and rename this to, okay, CS string, like a case-sensitive string. And then, this is one part regarding the schema. Second part, we need to define a field. So we will maybe copy definition for the string, and then we will here use CS string, and here we will use CSS. And then, in this example that I will not have time to go through completely, we indexed this additional field through the search field. This is a way for field types to define what they want to be indexed and how. So this is an override for the default search field for the text line field type. We basically fetch the parent methods, parent data, and then append case-sensitive string with some name. Remember that this is what the actual field name is generated from. Reindex everything, and we will get back the case-sensitive field that we can use on faceting that will return case-sensitive names. And that's it. This will have to be all for this time. So to close, particularly if you used EasyFind before, this is a different approach, different architecture, actually. EasyFind was more like plugin-like on Solr. So it was much more lower level, more stuff was open, and it was possible to work more closely to Solr than it is through this new Solr search engine. New engine, it abstracts a lot of things. It defines, in my opinion, much nicer API than the one we had with EasyFind, but of course it comes at a price. So you need to understand the abstractions in order to extend them and to change them if you need so. Another thing, the current state of the Solr search engine, it's in my opinion, the implementation is good. It is, however, true that it lacks some stuff. It's not complete. It needs to be worked on. And I hope that from this workshop you got a little bit sense of how this looks like inside, and maybe some interest to implement some stuff, to modify it, to extend it, because you will always find a need to do so. And that's it. Okay. If you have any questions, I think we can take a couple of minutes to do that. Yeah. Oh, we have a mic here for the recording, at least. Marek. Okay, it's on.
Hey,
Yeah.
quick question about the case sensitive you implemented.
Yeah.
In terms of performance, in comparison to full stack Solr lowercase indexing, do you manage to find a loss, or is it the same performance with case sensitive?
I don't think there will be any performance hit on this, because the field is, the data is analyzed and then it enters the index, and I don't think it will be any performance loss. Yeah. Anyone else? Okay, thank you again.